Now what we're going to do is move on to talk about matrix multiplication. We're about multiplying a matrix times another matrix. And, well, if we lived in a just and nice world, you would hope that matrix multiplication works the same way as addition and subtraction, right? That you just take them and multiply term by term. That'd certainly be convenient, but unfortunately, that's not the case here. And actually, with a lot of calculus, when you get to there, that's not going to be the case very often, that multiplication is nice. But what we're going to do here is a fairly complicated process that works something like a dot product, which is a notation, again, we might see later. But to understand it, we kind of have to start from the 2 by 2 case and work our way outwards, in a sense. So if we have two 2 by 2 matrices, A and B, where we're going to make them as general as possible, we're going to say that A is A, B, C, D, and B is E, F, G, H. Those could be absolutely anything. We're not trying to describe a specific picture, we're trying to talk about any pair of 2 by 2 matrices. If we want to multiply them, what happens there is we have to look at it in terms of sticking rows and columns together. So, when we multiply, let's think about the locations of what we're going to end up with. So if we're taking a 2 by 2 thing times a 2 by 2 thing, what we end up with is another 2 by 2 thing that in this case looks kind of ugly. But what happens is in terms of each of those spots, we're taking the row from the first one and the column from the second one. So it's kind of like going with that row by column idea, except taking it a step further in complexity, because we're talking about this multiplication idea, so it's a little bit more involved. But say for the 1, 1 position, which here has AE plus BG in the multiplication, what we do is we take the row from A, which is AB, and the first column from B, which is EG. We look at those to get our 1, 1 position in the product. Where to do that, to get that 1, 1 position, we take 1, 1 from here and 1, 1 from over there, that is 1, 1 in A, times 1, 1 in B, B, 1, 1, as it were, and then add to that A, 1, 2, that would be B, plus B, 2, 1, which is G. So we're combining rows by columns, where the cell in the product, the IJ spot, is going to come from row I in the first term and column J in the second term. So focusing down a little bit more just on that piece, we see it follows a pattern a bit like this. And then if we fill all of the pieces back in, we end up with all of the 4 elements fitting that pattern of combining row I to column J. And when we're working with this, like I said, we're going to start with 2 by 2, and generally when we're dealing with these, we like to have that the systems are square. Even though this isn't a very clean process, it's cleanest when that happens. Really what we absolutely need is that the first one has the same number of columns as the second one does rows. And when we look at some non-square cases, I'll give a bit more about why that happens. But for now, just understand that what we're doing, like I said, is thinking row by column to put together our new picture in terms of sums of products. It's not a clean process as you're getting used to it. It's another one of those things you just got to practice what the idea is here. And in the next part, we're going to get a little bit of that practice looking at a basic example with two 2x2 matrices.